Hey everybody, it's Jenny from Norman S. Wright. In the last couple of videos, I've mentioned motors a few times, so I thought it'd be good to do a video on the two types of motors we see in HVAC equipment. So today, let's talk about PSC and EC motors. Let's get started. PSC stands for permanent split capacitor, and EC, or sometimes you'll hear ECM, stands for electronically commutated motor. Until the late 90s, all commercial HVAC equipment had PSC motors. EC motors became popular in the early 2000s or so, and now are required for all fractional horsepower motors in a lot of places, including California, where many of Norman Wright's offices are. Let's make a little room here. I'm not going to cover a lot of detail of the internal parts of the motor and how they work, but let's just look at the basics. PSC motors are AC induction motors. They have two main parts, a stationary part called the stator and a rotating part called the rotor. The stator is like the outer shell of the motor. It doesn't move. Coils of wire that are connected to AC power are wound through it, and when the AC power is applied, it creates a rotating magnetic field in the stator. So you have this magnetic field, and then the whole field is rotating around. The rotor is located inside the stator, and it's designed to rotate. When the motor is turned on, the rotating magnetic field created by the stator induces a current in the rotor, and this causes it to rotate. PSC motors, especially small fractional horsepower motors, have efficiencies in the range of 55 to 65%. And the efficiency goes down as the motor is turned down to as low as 15 or 20% sometimes. Let's make some room again. You'll see single-speed and three-speed PSC motors. Single-speed motors can be controlled by an SCR, which is a silicon-controlled rectifier, that basically reduces the voltage to the motor to slow it down. Three-speed motors usually have a high, medium, and low tap. Let's make some room again. EC motors are brushless DC permanent magnet motors. They're DC motors that use a built-in inverter to convert AC to DC current, and they have an integral microprocessor. It has windings on the stator and a permanent magnet rotor. So unlike the PSC motor that has to generate a magnetic field, the EC motor's rotor is a permanent magnet. So controlling the repulsion and attraction of the different poles is what creates the rotation of the motor. This means no energy is wasted to create the magnetic field itself. The microprocessor monitors the speed and/or torque of the motor, and it also allows it to be programmed with a soft start, which is better for the motor. EC motors have efficiencies of 80 or 90% or higher, and they maintain that efficiency even at turn down. Let's make a little room here. EC motors have a wider operating range as well. This means that for any given size of EC motor, the operating range can cover several sizes of PSC motor. EC motor speed is controlled by a PWM, or pulse width modulated signal. This means that an output signal is pulsed over a specific period of time. For instance, if you sent an 8-second signal over a 10-second duration and then sent another 8-second signal, this would equate to an 80% signal. This is usually a 0 to 10 volt DC signal, but it can be also a simple potentiometer dial on the motor or the equipment. Let's bring it all back on screen. The driving factor behind the use of EC motors is efficiency, but the controllability of the motor and the high turn-down range are also benefits. The motor also is quieter and runs a little cooler than PSC motors. So I've been talking about fans lately in the Green motor, but other components in the HVAC system can have EC or ECM motors as well, such as fan boxes and fan coils. So that's the basics of PSC and EC motors. Don't forget to like and subscribe to our YouTube channel, and thanks for watching.